Hello, my name is Bryan Reyes, and today I will be talking to you about section 4.7 of the book, which is coordinate geometry and vectors. So starting off at the beginning of the chapter, it talks about and explains what a Cartesian coordinate is. It is, by the book's definition, is a system that also goes by the term of coordinate geometry. It is a system in which the location of a point is given by coordinates that represent its distances from perpendicular lines that intersect at a point called the origin, aka the x-axis and the y-axis. This is the concept and system that allows us to make graphs, charts, etc., such as the equation for absolute value, for x squared, for a linear equation, etc., etc. This is where our XY graph comes from. We must first understand each part of the system in order to move forward, though. So starting off, we need to understand the different parts of the Cartesian coordinate system. And so the Cartesian coordinate system consists of a few parts. Of course, like I said, it consists of the two perpendicular lines that form the planes, the x-axis, which is the left to right, and the y-axis, which is the vertical line down the center, where they intersect in the center and creates the origin point O. Now, along each of these lines, both vertically and horizontally, there are more perpendicular lines at certain points of these lines that help create this square grid where each of the points in the coordinate map can be drawn. All of these points are denoted by P, X, Y. And when we connect to these points, the result is a non-vertical line. So the equation of a line, it is, the equation for every line in a Cartesian system can be calculated using the linear equation, which is represented by y equals mx plus b, where m is the slope and b is the y-intercept, where the y-intercept being the part of the line that intercepts the y-axis, whether it be negative or positive. Now, to further expand on the equation, we also have a formula that helps us find slope as well as the distance of any line that we find with y equals mx plus b. So for slope and distance formulas, this is something that has been taught throughout all of high school in geometry class, where you find out that slope is rise over run, which according to the formula is y2 minus y1 or rise over x2 minus x1, which is saying the distance from point A to point B. Sorry, not the distance, is the inclination of these 2 points. Now the distance is what I was referring to previously, is where the distance is defined as the length between these 2 points, not the inclination. It is the distance or the length of this inclination or the line, where you would add point x2 and point x1, then square, and add that to y2 plus y1 squared, and then you square the entire thing. And you would get the single whole number, or just a number in general, that gives us the distance. And we use each of these components, the slope, the distance, all of that whenever we're talking about vectors. Now vectors, as the book states, is a column of two real numbers which are both called components, whereas one is on top and one is on bottom, one representing the x, the other representing the y. And it can be written as v is equal to bracket x over y bracket. Now, along with these vectors are a few properties that we use to manipulate and to understand vectors in certain different ways. The vector operations and properties that follow are a few basic, whereas it covers addition, it covers multiplication and combination between two different vectors, and also the 0 vector, which is implying that there is a 0 identity for vectors, which in this case is O is equal to 0 over 0. The sum of two vectors is simply adding the corresponding variables and getting a vector, one singular vector that adds the two variables from each of the vectors that correspond to each other, such as the case that I have here, which is u plus v is equal to x over y plus z over w is equal to x plus z over y plus w, giving us that one singular vector after adding the two together. It's the same thing with the scalar multiplication, whereas it is here you have some number a multiplying by u, and we distribute that to each of the values in the scalar, whereas we have a times x over y, the vector, and it's equal to ax over ay, which is our new scaled vector based off of the number being multiplied, which is a. And then of course we have the linear combination, where we have a scalar multiplication between two different vectors and adding each of these scalar multiplications together to get, again, one singular vector by adding two different scalar multiplications, where in this case it's a times u plus b times v is equal to a times x over y plus b times z over w. So then you distribute the a to the x and the y and the b to the z and the w, and then you add them together because of PEMDAS rules, and you end up with ax plus bz over ay plus bw, and that would be a linear combination. So going forward and talking more about scalars, we get into the scalar product, which also goes by the name of dot product, as well as the length of a vector. But going back to scalar product, it is, like I said, another property in the realm of the vectors. And we define the scalar product using this formula here, which is u dot v is equal to x over y, which is u, dot z times w. So another way to, another thing to call this is cross multiplication, where you multiply the x by the z, the y by the w, and then you add the two different products together to get your scalar product, wherein, like I said, where in this case you have x over y dot z over w, x by the z, y by the w, you multiply across, and then you get xz plus yw. And some additional properties that go along with scalar products is the commutative distribution and associative laws that are pretty obvious when it comes to the first given equation for scalar products. Now, when it comes to the length or the norm of a vector, it can be simply determined by using the equation the length of v is equal to the square root of v squared. Oh, I think I went too far. And some of the other concepts that the chapter goes into, not too much into detail, although it does give a couple of examples, is the law of cosine, which is uv is equal to the length of u times the length of v times the cosine of theta. And the vector equation for a line is equal to x, which is equal to t times a plus x starting point. And then, of course, the last one that is covered in this section is the vector equation, or for a circle. I'm sorry, that's a mistype on my end, which is the length of x minus c is equal to r, the radius of the circle. So this finishes up our discussion on chapter 4, section 7, which is 4.7. Thank you so much for your time. Bye-bye.